you're developing an alloy. So what are the different requirements for gigacasting in comparison to normal structural casting that requires a different alloy?
Well, from what we've seen, it's very similar to a primary alloy. And I mean, everybody's using a primary alloy today, and that's usually what we get on our table, saying, can you do something like this, but secondary? And then the discussions start then. They say, no, we cannot do exactly like that because that's primary. We have to tune it. We have to modify it somehow. But yeah, so I would say what they're using today is a typical primary alloy, 42,000 something. So in that series.
Ooh, I almost dived into that pool. 42,000 aluminum silicon 7, right? Welcome back to the Gold Casting Podcast. This podcast, as you know, is about aluminum casting and how to turn your aluminum casting business into pure gold. But before going further, we would like to thank you all out there in the audience, because we have a magnificent growth now in impressions, in views, and people. And we make a joke here just 2 minutes ago that we're like the Kardashians in the die casting industry. Maybe not more resemblance than that, but anyway, anyhow. Love having you out there, guys. Feel free, comment, ask us anything, or tell us what you want to hear in the next episode, and we try to make your dreams come true. So, after this little intro, being this happy, we're actually even more happy that today's episode about the gigacasting focus, we have Erik Petré with us. Welcome, Erik.
Thank you. Thank you, Staffan. Thank you, Fabian.
So, Mr. Petré, to give an introduction, is the head of the marketing and sales department of an alloy producer called Stena Aluminium. An awkward name. Aluminum is spelled in the Swedish way, so it is the first curious detail you have. We know you as a hardworking guy selling aluminum alloys that are super sustainable. But then I think the audience might want to know more about you, Erik. So could you please introduce yourself a little bit?
Sure. Thank you for that introduction. A hardworking guy, I like that. Well, I have a background within automotive, as many of us have. I've been around at a few tier ones, Autoliv, Magna, and so on. And my previous job before this one was at Shiloh Industries, where we produced a lot of cool stuff in magnesium and aluminium. And it's on that path I joined Stena. And also took a step down in the supply chain, in the hacking process from the buyer, one step away. It's been very interesting. I like it. It's been an amazing journey here at Stena Aluminium, being on the raw materials side of things instead. So I've been spending my life in the tier one area. So this is a new experience.
But isn't it always the scrap guys in the end that makes the money?
yeah, and that would be our.
I mean,
suppliers.
Everybody's focused on being the cool senior mechanical designer that make the next version of Teslas or Daimlers or BMWs. And the scrap guy, he goes there every day, and he got those clothes, that people think he's a poor guy, but kind of harvesting the remains of whatever. No one else. I mean, it's too unsexy, isn't it?
Well,
until now,
they're not fooling anyone today, I think. they have a good situation. Okay. But again, yeah, we produce based on scraps. So we buy the scrap. So we have, our biggest suppliers, or our suppliers, I would say, are the scrap dealers, which are very good guys, I would say.
That's perfect. Can we dig a bit more into that? Where does the scrap come from? How does it get to you? And then the second question will be, how do you turn that thing into an alloy that can be used for casting?
Sure. So scrap is, being collected all over. We belong to the Stena sphere, which is a fairly big family-owned company. It's not listed. It's privately owned. And we're part of Stena Metal. Within Stena Metal, we have another sister company to us called Stena Recycling. They have a lot of activities across Europe, mainly the northern of Europe. They have a big presence in Sweden, Poland, and so on. They go around and collect all these scraps from scrapyards. They sort of consolidate this into one big facility, or most of it, I would say. They consolidate into one big facility in Halmstad, in Sweden, where they sort out all the different metals, and aluminium being our preference then. they ship the aluminium to us, or we buy it from them, to be precise.
Mm-hmm.
So it could be anything. It could be, a building being teared down. You collect every material you have there, you put in different bins, and you make sure that the aluminium goes in the right direction to us. It could be cars. You shred cars. You get a lot of different materials in small pieces out of the shredder, and then you start the sorting process with all different kind of technologies. It could be magnetic, it could be sensors driven, it could be laser, it could be floating bath and so on. So you get the metal out of it in the different fractions. And of course, we spot buy from across Europe. If anyone have a good deal on used aluminium, we are interested.
So how is the link to gigacastings and structural castings and the die casting industry? I mean, years and years and years, you guys have been selling 44,300 and 46,000, right?
Mm-hmm.
And now people are asking for something else.
People are, yes. And not only that automotive industry, everybody's looking for something else, meaning they want to have more secondary material, more used aluminium scrap within their products. Mm-hmm. Gigacasting is, of course, very interesting. It's huge parts, a lot of metal that you're supposed to do something with. And if you do it with primary aluminium, you have a massive CO2 footprint. If you could reduce it to, 50%, or even go all the way to have a secondary alloy to do these mega casting, giga casting parts with, you would save a ton of CO2, literally.
Mm-hmm. Speaking about that ton of CO2, I mean, don't we have mutual friends out there and some OEMs that already have chosen to go with your newly developed alloys? We do, right? But we have still some NDAs to think about here. But do you see a trend that more and more OEMs are getting into the alloy producer for these discussions that didn't take place 5-10 years ago, that the alloy composition, the sustainability, all this has become hot stuff, that you see a much greater interest?
Yes, there's a big shift, I would say. From my time at the tier ones, sitting there selling these parts, not the mega castings, but other structural parts, the raw material was more something, it was specified on the drawing, and that's it. You got to use that one. So there was no discussion around it. Sure, it had a different, it had a separate line in the cost breakdown saying aluminium and then a price attached to it, but no more discussions about that, because everybody knew you could do it with that material, it will work fine, and you're supposed to do it because it's on the drawing. So we didn't have that much discussion with our raw material supplier. That was more on my company then, a purchasing activity to buy the material, to make sure we have enough material for the casting machine.
And you probably, as the tier one, you pick the cheapest one can do the job, and the rest is done.
Yeah, sure. I mean, typical purchasing activity. You come up with a specification, you make sure the supplier fulfill it, and then you go and search for the cheapest price, given everything else is fulfilled, which is normal and totally okay. But today we're sitting in other discussions, talking about how can you tune, how can you modify a alloy to make sure it still maintains the properties. So it's very interesting, and it's fun to finally start to having these discussions where many times it's over-engineered, I would say, on the material side. You don't need that fine primary material to make this piece. You can do it with secondary. It's okay. It will work.
But we see secondary alloys from your company coming out with quite extreme properties, quite extreme, I would say, chemical compositions. And we all know that these alloys are going pretty good on the market. We speak about Rio Cool, for instance. And again, for your dear listener, we're not yet sponsored by Stena Aluminium. So this is pure interest from my side. And given the interest, also looking at the automotive, where we look at, for example, body alloys with high elongations, able to keep that elongation also over the flow length, and you have all these things without the thermal treatment. You need a lot of pure scrap, meaning rolling mill scrap, extrusion scrap of that quality, basically 6082, 6063, and then so forth. Will it be scrap for everybody? Is the volume enough out there?
Well, initially, yes. In the long run, no, if you maintain the specification. So in order to have scrap for everybody, we have to look at the specification. How can you design the part in a different way? Or does it need to be different? I don't know. But if it has to be different, so you can fit in the secondary, then it would work, yeah. Or it would at least work for a longer time than if you don't do that. So if everybody maintains this high specification, very tight tolerances, FE cannot go beyond 0.2, then no, there won't be enough scrap if a lot of OEMs at the same time choose to do this.
I do have a more technical question. So you said 0.2, that's the usual limit in all the specification for the iron content. How much could you increase the recycled content if you could go to something like 0.3?
0.3 is still a challenge. We usually say 0.4 would be our lower limit. 0.3, we can do that, but in a limited volume, I would say. And everything has a cost. You can probably find more scrap, but then you have to pay for it. So
when you go to 0.4, 0.3 was just a number I just made up.
Yeah.
So what would be the difference in the recycled content between 0.2 and the 0.4?
0.4, then you open up a completely different area. Then you can start, then everybody have a different perspective of what is mass production, but it could be a big volume.
But you have a capacity of 92,000 tons in Älmhult. That is a big capacity.
Yeah, well, it's an environmental permit that says 90,000. 90.
And
yes.
For you poor listeners that doesn't know what Älmhult is, it's a small town in a very beautiful landscape. It's the same town that you will find the headquarters of IKEA. I have a question to you, Erik, because we meet foundries, we meet OEMs, we work with them all. Everybody says sustainability is important. Now comes a little bit longer story. We had this Eurogas. One guy came in and asked specifically about CO2e emission rates and stuff like that around reocasting. And to give a perspective, it was 3 days. We were standing with 4 people fully occupied, 9 to 5 for 3 days. Imagine how many hundreds of people we had. And one guy came in and said, hello, I'm in charge of sustainable castings. So giving a CBAM coming up in 2026 and all the scientific based targets we see from all car makers, I don't see the panic. I didn't see the knowledge trickle down to the guys actually doing the business on casted components. Is this your view as well, or do you mean something else?
A panic would be the wrong word. We too were at Eurogas, and we also had 3 occupied days with only guys coming in asking about sustainability. So it could be some different angle to what we're showing in our booth. But I would say, in order to get this going, really, on sustainability, you have to put a price tag to CO2. And that has to be global. I would say that's the only way to get forward. Otherwise, there will always be the same discussion. Everybody talks about sustainability, but when it comes at the end of the day, when you're going to pay, nobody wants to pay extra. I mean, sure, if you could get lower CO2, that's perfect. But I'm not going to pay extra for it. It's going to be a hygiene factor going forward instead. And I think that's how they're going to play it. Well, it sounds like the enemy. That's not the case. The OEMs, that's probably how they're going to put this into their RFQs. They're going to say, well, I need this and this specification. And also, I would like you to reach a CO2 no higher than whatever. And then, in that way, you can kind of steer your supplier base in the right direction. And then everybody would have to compete. There won't be any extra euros for the CO2.
But I have to dig in, because as an alloy supplier, most of the foundries expect a certificate days, carbon footprint, recycled content is that number. But then it starts to get really washy, as no foundry has any tracking what they use on natural gases or have the oil burners or whatever used for energy to produce the part that goes into the car. What's your take on that? To get more data also in the foundry, which you have to provide also.
Yeah, no, that's a very complex problem to get everybody to reporting in the same way. I mean, we have chosen one protocol, but there are several protocols. We are using the greenhouse gas protocol. And if you're going to follow that completely, then we should take into account what happens with our aluminium once it leaves our premises. But then we have to go to our customers and ask exactly all these questions and say, what are you doing in your site? And what's your footprint? And then we have to see what happens with the part when it comes to a car manufacturer. And then the car manufacturer have to say, and so on and so on. So it's going to be very difficult to fulfill this whole calculation. Our take on that and our view on doing this is that we stop calculating. Once we ship it out, then we let the customer take over. Add your calculations on top on our figures. If everybody was doing that, then we would have a fairly good figure in the end.
But you have gone from what 0.8 or so in an old PowerPoint. I was actually preparing for this, and last year on some alloys you had 0.47, and this year you have 0.366.
Yes.
I mean, how low could it be?
Potentially we can go to 0. We're working on that, trying to understand how we should do that. But again, then as it sits today, going to 0 is, I would say, it's feasible, but it costs. It costs, as it is today, a lot of money, because you have to invest in equipment and the process and so on and so on and so on. And I don't think, or I shouldn't say I know, because they haven't sent me a written confirmation on this, but everybody I've asked whether or not they're ready to pay extra for a very low CO2, they're very hesitant. So I would say it's not commercially viable today to do it with the technology that exists today of what we know. But this is a problem we have to solve, not only for aluminium, for all materials. So I think in this case, we have to figure out how to do it in a commercial way.
But aren't you afraid if you had a couple of customers saying that, yeah, this is great, we will support you, here's a 5-year contract, we'll buy everything you produce, you invest, I don't know, 200 million SEK or, 50 million euros or, I don't know, something like that. And then someone buys a certificate that they have these numbers from, let's say, a culture where it's more entrepreneurial when it comes to the truth. I mean, we have all seen people buying ISOs, diplomas, and whatever you like, and greenwashing will be super, super easy. You're not afraid that this will happen and actually kill your business. You do the investment, you show the way, and then someone cheats on the other side of the globe, and then they are to deliver.
I would say yes and no. Of course, it's a risk. In this case, if you would do all that investment, you would go into a long-term contract with somebody. You would do that with somebody you trust. And if you trust that, other partner, you would also trust them not to go outside of Europe and buy these made-up figures, if that's the case. Then. I understand your point, but I don't think that's actually a risk. It depends on what partners you choose, of course. I would say but that is a problem. How is everybody calculating? And in order to compare, we have to make sure that everybody's calculating in the same way. And it's a big challenge.
Probably would be easiest when we go back to our main topic, the giga castings, when you do the casting directly within the OEM premises, then to get a most sustainable solution, especially delivering these large amounts of aluminium, 3, 4, 5 tons per hour melting capacity is needed to produce the castings. Isn't that the perfect way to start such a discussion and such a calculation throughout the process?
Yes, that would be a good way, of course. Then you would control a lot of the emissions. You would have full control over. Absolutely. So that would be a great way.
Would you say that giga casting is the main focus for your business development, or is it just another component amongst others?
It certainly have a place in our business development, for sure. So we're focusing on it. We're following it. We're working on alloys, trying to develop a alloy that would be suitable for this, a secondary base one. So for sure, it has a big focus. But there's not so many doing it today and requesting the volumes. We have a few, we know them. But it hasn't really, how do you say, won the battle yet.
You're developing an alloy. So what are the different requirements for giga casting in comparison to normal structural casting that requires a different alloy?
Well, from what we've seen, it's very similar to a primary alloy. And I mean, everybody's using a primary alloy today, and that's usually what we get on our table, saying, can you do something like this, but secondary? And then the discussions start, and they say, no, we cannot do exactly like that, because that's primary. We have to tune it. We have to, modify it somehow. But yeah, so I would say what they're using today is a typical primary alloy. 42,000 something, so in that series.
Ooh, I almost dived into that pool. 42,000 aluminum silicon 7, right?
Yeah.
And according to me, the elongation people are asking is variating considerably. Someone over the big pond is talking about 8%. We have some Germans saying above 11. We have some local ones, I think, are filling around 10, and then I've seen 8 and 9 and everything. But how do you actually get an aluminum silicon 7 to maintain those properties over 1.5 meter flow length? I mean, they start to deviate considerably after like 60, 70 centimeters, I would say. elongation goes because you start to have defects and stuff, and then you have to lower your silicon. That's my point, to maintain the elongation.
Right, which is exactly what we're doing with the rear alloys, lowering the silicon. So yeah.
But that's kind of special field, everybody's not convinced that rear casting is the key to success, even if I'm a true believer.
Especially with lower silicon, the castability goes down the drain. LSE7 is already a challenge, and if you have to go deeper down, it's not getting more easy, and especially after 1.5 meters.
Yeah.
Then they have to call me out.
Most of the alloys we supply is around 10%, so 10 up to 12. So
yeah. But isn't it true to say that the only reason why we pour in silicon is to get the castability and high pressure die casting? Because all these alloys have 1 or 2% of elongation. They're brittle. They're pretty crappy.
That would be the old truth. Yes, have it float out nicely in the cavity. Yes.
Then comes my question, actually, because we have a big pile of cars out there, diesel and gasoline. If we get into EV or electrification on a higher level, let's say that every second car sold is an electrical vehicle or more, we will have a big pile of scrap that nobody wants. That's my conclusion.
Because you have high silicon in the material.
Yes. It's 46,000 ADC12. No one wants to use that for a shock tower, a battery box, compressor housing, maybe. But most applications in an electrical vehicle demands better material, higher elongations, and heat treatable in a different way. Look at the e-drivetrain. You were speaking pretty much about heat dissipation from electrical motors. We had water-cooled electronic coolers. They're not speaking about the aluminum silicon 10. They want something else. So you see my problem here. You have a big pile of 226 ADC12, aluminum silicon 10, 11, 12, something. And then all of a sudden you're supposed to support this car industry with lower silicon, lower iron, lower manganese, lower copper to make these big parts. And then they say, and we want it secondary. I mean, isn't this equation impossible to solve?
Well, if you put it to the extreme, then yeah, probably. But what happens in reality, as of today at least, is that we happily receive this kind of material if it has a high silicon content, because we use it so much. We have to add a lot of primary silicon into, to creating our alloys that we do today. So if we take one of the 44300, for instance, there is up to 11% silicon something. We use a very pure scrap to produce that, meaning there's not so much silicon coming in as a secondary. So we have to add primary into it. That's also one of our, call it, dirtiest alloys because of this addition of primary material. So we would happily receive this. So we can, add it into the mix and then reduce the amount of primary virgin material that we have to add.
So what you're saying is that silicon is a great CO2 driver.
Oh yeah. It's one of the biggest for us. It is the biggest for us.
What's the carbon footprint of silicon?
Well, it's different figures as normal, depending on where you look from. So it could be anything from 4.5 up to whatever, almost kilos per kilo. So it's very dirty, as all the primary. We buy our from the cleanest ones, produced in Norway. So a lot of hydropower used to produce it. But it still carries a very high CO2 compared to reused or recycled. So
what you're saying is that if you use Twitch or Sorba, you melt it in Elmhult, and then you have to pour in silicon, and by doing that, you send out a lot of carbon dioxide into the atmosphere.
That's the case. Yes, as soon as you have to add primary, and we have to add magnesium, manganese, strontium, all of this stuff to get to the customer specification, and all of them are primary elements that we add in. We do have a lot of recycled copper. So as soon as we have to add copper, it's actually recycled, so which is good. But I mean, that would be one of our goals long term, to minimize the alloying element. If we could reduce that would be perfect, because that carries a lot of CO2 in our calculation, in our setup.
So the best thing will be if everybody started to cast Sorba or Twitch, as it's called, when you take a car and you shred it into something small and then just melt it. aluminum, silicon, 4 5, Fe, Cu, titanium, and some bolts and nuts as well. And you get what you get.
In a perfect dream world, the car would go into the shredding, and then out you will have like 200 different piles with all the materials separated only by itself. That would be perfect.
Yes, I need very fine tonsils to take out every atom individually.
Yeah. Yeah, you understand how difficult this is, but that would be.
Yeah, aluminium is quite bad in this thing. That's very low potential. So if you try to get it out, you get the aluminium out, not the other elements you want to get rid of.
And I mean, we're part of it. We're adding.
Yeah.
Yeah, I was working in a steel plant doing my exam project report in Ovesta, Sheffield. Tremendous summer. It was Sweden had a great soccer team. It was very hot. The fishing was good, and it was also interesting working. The thing was that I never seen a scrapyard that organized. I've seen yours as well, but my point is, I think the steel people are better in scrap handling than aluminum people, because the molybdenum steels, the chromate steels. You have the Sheffield DeLong diagram, meaning that you have 4 different major compositions, and within every composition, you also have grading to just keep down the additives you have to put into the steels. It was stainless steel, by the way, and not this black steel that you can boil more or less at home. So quality steel, but still proud of it. Yeah. Never seen it since then. This extreme sorting and extreme control of the scrap. Never. I've seen your scrapyard. It's very nice. I've seen others that are looking like, ooh, really. But still, I think when you take a car apart, should be more piles of different materials than it actually is as of today. They are not designed for destruction.
No, not currently. But this is an aspect that they're talking about when designing cars today. So and that's fairly new, I would say, that they're talking about it. But they have to make it easy to disassemble. And that's probably going to be legislations around that going forward, that you have to be able to disassemble a car, for instance, in a certain way. Just because of this, we need to be careful with the resources. We have to take care of all the materials. We cannot put this into a big mix that nobody can use. That's not sustainable. So that's going to grow.
But a gigacasting would be perfect for that, because it's just one big thing. Dismantle it, and then you have a large pile of one alloy that can be easily recycled. Yeah. And you don't have to go through the shredder, take out all the bolts and nuts and rivets.
Yeah,
and have to check which material is which.
Another good example are the wheels, the rims. I mean, it's almost every time the same alloy, and you know that. And the guys that have been around for a while, they can maybe spot a few that is not the correct alloy. But there are 2 alloys, basically, and 90% is one of them. So, and that's perfect. You take those wheels off, and then you have a perfect material that everybody knows the specification of. Just take away the organic stuff, and then you're good to go. It's a very good material.
See that, in my line of work, I see that happening in North America, this EcoMelt thing that is going around. We have done a few parts with EcoMelt, but it doesn't exist the same circular model in Europe yet. Do you know if this is happening, or is it just North America?
I don't know if that's coming. I don't know if that's coming. I know they have a different system in US, which allows EcoMelt, for instance, to conduct their business in a good way. It's not that easy in Europe. So here it's up for grabs in Europe. So it goes on spot sales. Yeah.
And I heard a lot of these wheel manufacturers want to keep their wheels in a closed loop cycle, as the spot market is more expensive than buying directly from their customers back.
Right. Yeah.
So if you see your neighbor has put his car up on piles and you don't see any wheels, then you know it's harsh times in the economy.
Yeah, then it's bad times. Yeah, we always have a couple of
24th of the month, and you have to pay the grocery shopping. Okay, the wheels have to go, honey.
And you see someone with 4 emergency wheels driving around.
Yeah, made of steel.
That's bad. Ooh, that's bad. A funny thing, we had a professor in aluminum at the Royal Institute of Technology. Imagine, I was actually going to that school, and he was talking about aluminum, and it was the savior of the world, hours and hours. And then finally some student asked, is there anything that's not better off in aluminum? And I was thinking a little bit, and then he said, well, wheels for cars, the rims. because if you do it in sheet metal, they look ugly, but they're actually lighter and stronger. So
I remember when you were buying your first car a long time ago, you of course wanted the aluminium rims. And if you could get hold of like 16-inch, that would be great. But it was also saying, the old saying was that, or at least from my father and all the other older guys, that you shouldn't have that in the winter. They always break. So then you need the steel ones. Yes.
Yeah.
Could be an argument just to save money also. I don't know.
I don't know actually how we survived that. I mean, my first car was a Ford Taunus, but something similar. And it was so light, so I had 2 big bags of sand in the back, because otherwise, the rear end actually met me in the curves in the Swedish winter. And even if I got studs, and it was so amazing. It drank 1.3 liters per 10 kilometers. Metallic green it was. And I was so proud of it, but I could never afford those forged rims that everybody, the cool guys had. But when I bought it, I had this leopard fabric on the seats. You can buy extra on to save your seats, and the pattern was leopard. Imagine that car today.
Yeah, well, big recognition. I had an Opel Manta.
Opel Manta was too expensive for me. So, but the Ford Granada I could afford. I mean, no anti-spin, no ABS, drank fuel like crazy. It had some 120, 130 horsepower, so it was pretty good in the summertime, 0 to 100 in Hallstahammar outside Västerås. But on gravel roads, it was like a battery in a hot pan like this. And still I survived. I don't know how that happened. Anyway, no airbags. Skills. Oh, thank you. How much do you want to borrow? It's harsh times in Stena. They took off the rims from the car, and so
yeah, I already took your rims. It's okay.
The CEO comes out for driving home, 5, 6 o'clock there in Helmut, and his car is bumped up with a note from Bosse at the scrapyard. Needed some more material. Sorry.
Yeah,
that's a circular economy.
Yeah, definitely. Especially the wheels are circular as well.
Yeah,
if I think back at my first car and it got the other ones, it's just these cheap starter cars, and then people started to put in after the summer job some nice wheels, and said, okay, that's the easiest way to double the value of your car. Just put in these wheels.
Yeah, absolutely.
but the funny thing is that you had this crappy car, and then you start to spend money, and you always get the feeling that it's like putting makeup on a pig. It's still a pig. It's like, why do you do it?
Yeah,
no, definitely.
Yeah, you got a piece of paper showing that at the annual inspection. That was like winning a lottery if you could get your car through that one.
Exactly. And the more parts you put in, the more difficult it is to get the paper.
Yeah, that's actually a problem with the driving motorcycles, because by tradition you always exchange the exhaust system because of the sound. So there's a big aftermarket for quick coupling, so you can actually slide on the original one when you're going to pass this to get that paper that you're worthy to drive on the street. Yeah, things happen sometimes. They do. We actually put nitromentan, in a small motorcycles when I was young. But what you use for dragsters, And my God, they were fast for 50 minutes before they broke down. Oil over everywhere. Yeah. Anyway, guys. So Erik, a long life and many years to come. But if you had met yourself being like 24 years old, just before entering our dear industry of die casting, and you could give yourself an advice, slightly older Erik is giving the younger Erik an advice for having a fruitful life, making a lot of money, having a fun time, what would that advice be?
Yeah, well, you said it in the beginning. Be a scrap dealer.
That's great.
No, jokes aside. No, it's a good question. I guess everybody gets this question sometime. Would I have chosen automotive again? I think so. Yes. It's a lot of fun. It's a lot of energy, and it never gets boring, but it's also pretty hectic. You have to put a lot of work into it, as you guys know. So, but again, I'm not at all dissatisfied with my choosing of career path. I like this industry. It happens a lot. We do get a lot of bad publicity. Have always been given the automotive industry. It's always a bad thing. So it's looking forward to the day where we can produce a net zero car, and the only thing you can complain about is actually the size of the car being in the way, but not the emissions. That would be nice.
Or the infotainment system.
Probably that one.
Good, great.
Well, they have been much better.
The infotainment system.
Yeah. I mean, compared to 20 years ago, you're a fantastic car there.
Yeah, 20 years ago, the infotainment system was a radio, and it was amazing if it had a color display.
That would be nice.
Yeah, but guys, yesterday I started in Skillingaryd. For you who doesn't know what Skillingaryd is, the home of Rio casting, first of all. It's the center of semi-solid casting in the world. Yet, it's a small town. South of a town called Jönköping. I got 410 kilometers going home. After 220 kilometers, my infotainment system finally accepted my cell phone that I had been using every day in that freaking car. This car is built in Bayern, and you do the math. So, I don't know, my Blaupunkt, with the cassette actually did work pretty trouble-free in my Ford Granada. So, being the grumpy old guy that loves diesel in the room, okay, we can debate that further.
Yeah, I think that's a discussion for another time.
Yeah.
Nothing to do with alloys.
I think we have to release for Erik here, because otherwise we will keep him for the full night. But it was a great honor to have you on board, Erik, and happy to have this talk with you. Insightful.
Thank you very much, guys.
I'm sorry that we came into technology that much. We were supposed to just be about money in this podcast, but sometimes you fail. But you have to give the background to the viewers and listeners. So it was great. Thank you very much.
Thank you for being here. It was an amazing deep dive into the alloys and how the scrap market works and how to get to alloy you can actually use. That was a really interesting episode. Follow for more episodes, and we see us in the next Gold Nugget. Thank you for listening, and goodbye.
Sayonara.